Where did we come from? This profound question has been at the heart of human curiosity for millennia. From the earliest civilizations to the modern age, we have sought to understand our origins. It's a question that has echoed through the ages, resonating in the minds of philosophers, scientists, and dreamers alike. Ancient cultures built observatories and temples aligned with the stars, seeking answers in the heavens. Humans have long gazed at the stars, pondering our place in the vastness of the cosmos. The night sky, with its twinkling stars and distant galaxies, has always been a source of wonder and inspiration. How did life arise on our pale blue dot, seemingly alone in the vast cosmic desert? This question leads us to explore the very nature of existence and the conditions that made life possible on Earth. Was it a magnificent accident, a chance occurrence in the chaos of the universe? The early Earth was a tumultuous place with volcanic eruptions and meteor impacts creating a harsh environment. Or could it be something more, a deliberate act by a force beyond our comprehension? Scientists conduct experiments to unravel the mysteries of DNA, the building blocks of life, while pondering the possibility of a higher power or cosmic design. These questions have perplexed scientists, philosophers, and theologians for centuries. Each discipline offers unique perspectives, from the empirical evidence of science to the existential inquiries of philosophy and the spiritual insights of theology. They are fundamental to our understanding of ourselves and our place in the universe. By seeking answers, we not only learn about our origins but also about the nature of life itself and the potential for life beyond our planet. As we delve into the mysteries of life's origins, we embark on a journey of discovery. This journey takes us from the depths of the oceans to the far reaches of space, from the smallest molecules to the grandest scales of the cosmos. It is a journey that takes us from the smallest molecules to the grandest scales of the cosmos. Along the way, we uncover the intricate connections that bind us to the universe, revealing the profound beauty and complexity of life. Imagine our planet billions of years ago. The young Earth was a chaotic and volatile place. Volcanoes erupted, spewing molten rock and gases into the atmosphere. Lightning storms raged across the sky. The oceans were a swirling broth of simple organic molecules. This primordial soup, as it is often called, was the crucible in which life is thought to have emerged. The building blocks of life, amino acids, lipids, and nucleotides, swirled and interacted in this chaotic environment. But how did these simple molecules assemble themselves into the complex structures that make up living organisms? This is the central question that the theory of abiogenesis attempts to answer. In the 1950s, a groundbreaking experiment offered a tantalizing clue. Stanley Miller and Harold Urey simulated the conditions of early Earth in a laboratory. They filled a sealed flask with water, methane, ammonia, and hydrogen. These gases were thought to be present in the early atmosphere. Electric sparks simulated lightning strikes, providing energy to the system. Astonishingly, after just a week, the experiment yielded amino acids, the building blocks of proteins. The Miller-Urey experiment, while not definitive proof, demonstrated that the basic ingredients of life could arise from non-living matter under the right conditions. This experiment was a major milestone in the study of life's origins. Section 4, the Code of Existence. While the Miller-Urey experiment was groundbreaking, it only scratched the surface of life's complexity. The true marvel lies in the intricate molecule known as DNA. DNA is the blueprint of life, containing the instructions for building and operating every living organism. This molecule is incredibly complex, a double helix structure composed of billions of chemical bases arranged in a specific sequence. The sheer improbability of such a molecule arising by chance is staggering. Some scientists argue that the random assembly of DNA is akin to a hurricane blowing through a junkyard and assembling a Boeing 747. This apparent paradox has led some to propose alternative explanations for the origin of life. Section 5. A guiding hand. The concept of a higher intelligence or designer has been a recurring theme throughout human history. From ancient civilizations to modern times, humans have always sought to understand the origins of life and the universe. This quest for knowledge has led to the creation of numerous myths, legends, and scientific theories. Many cultures have creation myths that attribute the origin of life to a divine being. These stories often reflect the values and beliefs of the societies that created them, offering a glimpse into how our ancestors viewed the world around them. For instance, in ancient Greece, the gods were believed to have crafted humans from clay, while in Hinduism, the universe is said to have emerged from the cosmic dance of Shiva. This idea, often referred to as intelligent design, suggests that life's complexity is too great to be explained by chance alone. Proponents argue that the intricate structures and processes observed in nature point to a purposeful creation. They believe that just as a watch implies a watchmaker, the complexity of life implies a designer. Proponents of intelligent design point to the intricate workings of cells, highlighting the sophisticated mechanisms that allow them to function. From the replication of DNA to the production of proteins, the processes within a single cell are astonishingly complex and efficient. The elegance of biological systems, such as the intricate patterns found in nature, further supports the idea of a guiding hand. The symmetry of a butterfly's wings, the spiral of a seashell, and the branching of trees all suggest a level of design that goes beyond mere chance. Additionally, the fine-tuning of the universe is often cited as evidence for intelligent design. The precise conditions required for life to exist, from the strength of gravity to the properties of water, seem almost too perfect to be coincidental. This has led some to believe that the universe was specifically designed to support life. They argue that the universe appears to be designed for life, with physical constants and laws perfectly calibrated for its existence. The delicate balance of forces that govern the cosmos, from the nuclear reactions in stars to the orbits of planets, all point to a universe that is finely tuned for life. With physical constants and laws perfectly calibrated for its existence, the universe seems to operate with a precision that suggests intentionality. The exact values of these constants, such as the speed of light and the gravitational constant, are crucial for the stability and development of life. Could this be a sign of a cosmic architect, shaping the universe and setting the stage for life to emerge? The question remains open, inviting us to explore the mysteries of existence and the possibility of a guiding hand behind it all. Section 6. The Universe. A delicate balance. When we look out at the universe, we see a cosmos governed by precise laws and finely tuned parameters. These laws and parameters are not random. They are the result of billions of years of cosmic evolution, leading to the intricate and harmonious universe we observe today. The fundamental forces of nature, such as gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, all play a crucial role in maintaining this delicate balance. The masses of elementary particles like quarks and electrons are precisely what they need to be to allow atoms to form and interact in ways that make chemistry, and thus, life, possible. The expansion rate of the universe, set in motion by the Big Bang, is another critical factor. If it were slightly different, the universe could have collapsed back on itself or expanded too rapidly for stars and galaxies to form. Even slight variations in these constants could render the universe sterile, devoid of stars, planets, and life itself. For instance, a minor change in the strength of gravity could prevent the formation of stars, while a different electromagnetic force could alter the chemistry of life. This fine-tuning has led some physicists and cosmologists to invoke the anthropic principle. This principle suggests that the universe's laws and constants are as they are because they allow for the existence of observers like us. This principle states that the universe must be compatible with the existence of observers, namely us. It implies that our very presence in the universe is a clue to its fundamental nature. In other words, we observe a universe fine-tuned for life because if it weren't, we wouldn't be here to observe it. This idea challenges us to think deeply about our place in the cosmos and the remarkable conditions that make our existence possible. Section 7. Myths and Mysteries. Throughout history, cultures across the globe have grappled with the mystery of our origins through myths and stories. These narratives, often deeply ingrained in cultural and religious beliefs, offer diverse perspectives on the creation of life and the universe.